Alright, so here's where we started off with day 2. These are changing equations, and everybody seemed to really understand this a little bit more because it's a lot more algebra based. So hopefully you guys find the same thing. Our goal for these first problems, we're changing from rectangular to polar. So rectangular is when we have x's and y's. What we want to change to is polar, where we have r's and thetas. So our goal is to change over the equation completely so that all the x's and y's go away and r's and thetas are replaced in there. To do that, we're going to be doing some substituting. We're going to use the same formulas. These 4 formulas over here are the same formulas that we saw yesterday, but we're going to use them and plug in. So when it says x, I'm going to plug in what I know x equals in terms of r and theta instead of being in terms of x and y. So I'm going to plug in the r cosine theta, and that's going to get squared. And then for y, we know y is equal to r sine theta. I'm going to plug that in, and that whole thing has to get squared. And then the equal to 9 stays. So then here what's going to happen is the squared does need to get distributed to both of the things that are in parentheses. So it's going to turn into r squared cosine squared theta plus r squared sine squared theta equal to 9. And then our goal with these is that you always want to, when you're doing the polar ones, your goal is to solve for r. So you need to keep that in mind. And you should see 2 things here that you kind of want to get together. I like cosine squared and sine squared together because that's going to remind me of something that's on the back of the plate, which we're going to use a little bit of. A little bit of the identities are going to pop up today. So the key is to factor out the r squared. If I want to solve for r, there can only be one r in the problem. So I'm going to take out the r squared, and I'm going to be left with cosine squared plus sine squared equal to 9. And then if you remember cosine squared plus sine squared, that's just 1. So then this is just r squared equals 9, and your goal is to solve for r completely. So I want to take the square root to get r all by itself. Our answer is r equals 3. Let's try another one. In number 2, we have an x value here. We have that x is equal to 10. So I'm going to look and see. I know x is equal to r cosine theta. So I'm going to plug that in. So we're going to r cosine theta is equal to 10. And remember, your goal is to solve for r, is we want to get r by itself. So if I want to get r by itself, I have to divide the cosine to move it to the other side. So we'll divide by cosine. And then our rule with these is that we want to simplify as much of the trig parts as we can. So if I simplify this trig part, I don't really want to leave the trig on the bottom. I don't want to have a fraction in my answer. It just looks messier. So we want to, if you need to, you can write these separately, but we want to change that to something on the back of the plate. 1 over cosine, its reciprocal is secant. So that's going to be secant, and this is how we'll write the answer. R is equal to 10. You don't have to have the times in there. It's just 10 secant theta. All right, let's try another one. Here's another variation. So again, the first thing I'm going to do is I know I'm trying to change to r's and thetas, so I'm going to substitute what I know. I know that y is equal to r sine theta. And then I'm going to plug in, this one has an x and it's squared. So remember, when we square it, we need to distribute that squared. So it's going to be r squared and cosine squared theta. So your focus again should be on the r's. We want to solve for r, so we need to get them together. The smaller one is the one that should move towards the bigger one. So I divide by r to get them together. You don't want to subtract them because there's nothing that has subtractions in any of our formulas, so you wouldn't want to move that by dividing. So the r's there cancel. We have sine theta is equal to 1r cancels here, so we still have 1 left, and that's the one that we're trying to solve for now. So I need to divide the cosine squared theta to the other side to get it by itself. You're trying to get that r squared all by itself. And then on this side, we want to simplify the trig stuff down. So I'm going to break that cosine apart. I like sine and cosine together in one fraction, but since it's cosine squared, there would be another cosine left over on the bottom. And then we're just going to simplify those. Sine over cosine is tangent, and 1 over cosine is secant. and that is our solve for formula. Secant theta times tangent theta equals r is the polar form of that same equation. Alright, let's try one more. This last one just has a little bit more algebra to it. We're still doing the same idea here, is I want to find what x equals. X is r cosine theta. I can plug that in, so that's 3 times r cosine theta. Since it's times, they can all just go next to each other. Minus, I know what y is. Y is r sine theta, so we're going to plug that in. And then it'll be plus 2 equals 0. So remember, our goal is to solve for r. So the first thing I would do here is the 2 doesn't have an r in it. Let's kick it off to the other side. It's got to get away from the r's, and we can move that to the other side since it doesn't have an r attached to it. Then this goes back to the fact that there's 2 r's in the problem. I can't solve for it if there's 2 r's. So what we have to do next is we have to pull it out so that we can get there to be only a singular r in the problem. So if I pull that out, I'd be left with 3 cosine theta minus sine theta equal to negative 2. And now it's recognizing that we only have really one step left here, is the r is being multiplied by that whole group that we pulled it out of, so we can move that whole group to the other side simply by dividing to cancel out the multiplication. So it's going to be divide by 3 cosine theta minus sine theta. We got to do that same thing on this side. These guys cancel, and we get r is equal to negative 2 over 3 cosine theta minus sine theta. And that's our simplified answer. We're not going to do anything, there's nothing easy to do trig-wise with the things on the bottom. There's no easy rules to follow, so we're just going to leave them there. Alright, now we're going to go the other direction. So the other direction, we are in polar form, which means we have r's and thetas, and we're trying to change it so it only has rectangular form, which is x's and y's. So anything that has an r or a theta, we're trying to swap out. So these ones you have to think a little bit more for. Is right now this formula has r, but if I look over here, none of these guys over here have an r by itself. So what we can focus in on is if you look at the bottom two, those are kind of our focus for these first couple of problems, is there is an r squared. But if I want to substitute in, that means I do need to make this side have an r squared. So what we can do here, since the other side's a number, is we can just square both sides. We get r squared is equal to 4. And then I can replace, I now know that r squared is equal to x squared plus y squared. So we're just going to plug that in. X squared plus y squared is equal to 4. And that is my polar answer. If you remember anything about the equations of conic sections, you would notice that this is the equation of a circle that has a radius of, if you take the square root, 2, which is the same thing that it says in the polar coordinates. It says that it's going to be anything that has a radius of 2, which would be this whole second circle. Alright, let's try another one. So this next one has a theta in it, and only a theta. So when you look at our options, the first one has an r and a theta, we can't use that. The next one has an r and a theta, we can't use that. The next one has just r. It's this equation we want to focus on because that's the one that has just theta. So there's no r in this problem. We're going to try and use that one. And we can write this down. We know tangent theta is equal to y. And the way I suggest to do these is we can just substitute. I can plug in what theta is. I know theta is pi over 3. And then your next step is going to be to look at your plate now that we have this value here with the radian value. You can use your plate to figure out what the tangent of pi over 3 is. The tangent of pi over 3 is just radical 3. So we get radical 3 equal to y over x. And then we're going to follow the rules of like basic algebra as we're going to solve this for y. Since there's just an x and a y, we typically solve it for y. So to solve for y, we would multiply each side by x. And that would give us radical 3x is equal to y. Or if we write it the other way, y is equal to radical 3x. That equation is in the form y equals mx plus b, which is just a line. And if you look at the picture, we get a straight line here. it has a slope of radical 3. That's in both forms. We get a straight line in the rectangular form, and in the polar form it says that we would want to be anywhere where theta is equal to pi over 3, which is that whole polar axis, so they're the same graph. Alright, and the last two examples, what we're going to see, the difference is these have an r and a theta. So if it has an r and a theta, we're really focused in on these two because those are the ones that have both of them. So we would like to see something that says r cosine theta or r sine theta. So the first thing we want to do with this one is we want to rewrite this. We want to rewrite the secant, because that might be helpful here. So if I rewrite secant, that's really 1 over cosine theta. And I really would like it if the cosine and the cosine theta and the r were on the same side together. So I'm going to multiply both sides by cosine theta, and watch what happens here next. We get r times cosine theta is equal to just 1 left on the other side. And we know that r cosine theta, and then we know r cosine theta, we can just replace from over here. R cosine theta is really just x. So we get x is equal to 1. And if you look at the graph also has a line that would represent x is equal to 1, which is the same graph as if we graphed it r is equal to secant theta, which we're going to be getting into those graphs more on Monday. Alright, one more page. On the last page here, we have r is equal to 4 sine theta. So we really have to think strategy here on what we can do, because again, we have an r and a theta, so I'm focused on these two. But the problem is the r and the sine are on different sides. There's no way to get it to be r times sine theta with the r and the sine that are already there. So we need to think a little bit about things we could do. And this one, there's kind of two different ways of doing this. So I'm first going to show you the book way of doing it. The book's trick is to recognize that we could do something on the left side and on the right side to get something that we could substitute on both sides. So with r, we really like r to be squared. But if I squared both sides right now, that's going to give me something on this side that's not really going to work out to my favor. It's going to be 16 sine squared theta. There's nothing. I have to get that theta replaced, and there'd be nothing to replace it. So instead of squaring it, since there's an r here and a sine here, we can multiply both sides by r, and then watch what happens. I get the r squared that I wanted, just using a different method. But then on the right side, I'm going to get 4r sine theta. And this is the part that's important, is r sine theta has something over here that can be replaced. So we're going to replace that. We're going to replace the r squared. And we're going to plug those in. So r squared is going to become x squared plus y squared. And then it's going to be 4. R sine theta is going to be y. And then with these, because of the type of equation they are, we like to put these in what's called general form, which means all the variables are together on one side set equal to whatever is left over, which happens to be 0 in this problem. This actually is going to give you the graph of a parabola, again, if you remember anything about conic sections. The other way to do this one, this is the way I thought of originally, is to really focus in on that sine theta and take this and say, well, I can solve it for sine theta. Sine theta is really y over r. And if I replace that, I would get r is equal to 4 times y over r. And then my next step would be to get rid of that r on the bottom, multiply both sides by r. We get r squared is equal to 4y, which we're almost at the same exact place we were before now, just a different way of getting there. R squared is really x squared plus y squared equal to 4y, and then we would subtract the 4y. So we get the same answer, just a different method of doing it. If you really got stuck and didn't see that you could multiply both sides by r, there's a way to manipulate the equations to get there as well. Alright, I hope you find this helpful, and I look forward to seeing all you guys back in class on Monday.